Hello, a very warm welcome to everyone who has joined us for today's Tech Tuesdays webinar on EDC custom resource and lineage automation. Today we have with us Rakesh Verma and Sachin Jain, who are customer success technologists with years of experience in data integration, analytics, business information management, data warehousing, and data governance with Informatica. Let's go through some housekeeping tips before we start this session. The duration of the webinar is 1 hour. That includes a 15 minutes Q&A. You can post your queries in the Q&A box. Dial-in participants are muted for the entire session. The session is being recorded and will be available in the Informatica Support YouTube channel and the Success Portal. You'll be able to download the slide deck from the Success Portal as well. Please feel free to put in your feedbacks and suggestions for the session in the post-webinar survey. The Tech Tuesdays webinars are hosted within the Success Portal, which is a microlearning platform that offers free and unlimited learning to all registered users. This feature-rich platform was launched to help you learn and use Informatica products better. We have launched a data governance learning path in the Success Portal that will enable you to implement data-centric approach to compliance based on your role. Here are a few important links that you can go over later that will help you in your product adoption journey with Informatica. Over to you, Rakesh and Sachin. Thank you.
Hi, good morning all. This is Rakesh from Customer Success Group. I'm working as a technologist and supports data governance product adoption journey. Today, we are going to discuss about how can we automate EDC custom scanner input files using IDQ workflows. So in today's session, myself and Sachin Jain from Customer Success Technology team are going to walk through you on this session. Okay, let me start the presentation. So for today's session agenda is I want to go through the overview and what is the requirement or a use case when you can use this framework, how we have done the design, okay, solution scope and automation flow, how the automation framework works. And at last, we are going to give a demo on whatever the artifacts we have developed as part of this framework. Okay, let me jump into overview. So the overview is we have created a framework. So basically, which allows EDC customers who wants to create custom metadata scanners and custom lineage scanners. Basically, they need to generate the input files, the object.csv file, which has link and object file, and custom lineage file or a lineage file, comma separated file needs to be generated whenever you want to extract custom metadata or you want to extract lineage into EDC. So basically, what we have, the products we have used to develop this framework are Informatica Data Quality and EDC REST API framework we have used. So the first and foremost step will be, there will be one-time manual task which needs to be done. That will be creation of a custom model. So basically, whenever you are creating a custom resource, okay, you need to create a custom model. And based on the custom model, you're going to create a custom resource type. And you can use a resource type and create multiple metadata resources, custom metadata resources, if the model is same. And this framework can be reused to accommodate the data extraction from multiple input files, okay, into multiple input files and create a input files for custom metadata and lineage resources. So let me move on. So the requirement, when you can use this framework, the customers who wants to reduce the manual efforts in creating input files for EDC scanners. Okay, so you don't want to generate the files manually by both metadata or a lineage scan into EDC. You can extend this framework to meet your custom file creations for different data models. So the current framework or IDQ automation is designed in such a way that it can handle 4 layers of data model, that is project, folder, and model and table. at a high level. Now, if you have a different model or a framework, different model, then you might need to tweak the custom model and recreate the custom model and custom method, custom resource, and then update or tweak the logic in IDQ to accommodate your new data model. Now, the one more the other benefit is that you're not expected to do manual intervention, or you're not expected to do a manual work in creating the file. Whenever you do a manual work in creating custom files for EDC scanners, you might induce errors. Okay, these might be the scenarios when this framework will be useful. Okay, now let me move on to the design. The way we have done the design is so data is flowing between two data sets, DS1 and DS2, maybe source and target. Okay, where data this can be any metadata scanner, this can be any native scanner like Oracle, SQL Server, or any Google or cloud sources where data is flowing. So this you can have a simple lineage CSV file to represent the data flow between two objects, two technical assets columns. Now you want to complicate or add some complexity around the lineage, like trying to show some description and the logic that is flowing between two objects. Okay, that is exactly what we have developed here. So initially we are expecting an input file for this framework to work. The input file will be, I'll show you sample when we go through the demo. The input file at a high level will be having the required input sources like project, dataset, and then schema, and table and columns. In the same way, you will be having the target, project, dataset, table, and columns. So, and not only that, you can also add the logic, technical logic, whatever you want. You want to add an expression, yes, you can add that expression. And then you want to add some description for better understanding of your lineage, yes, you can add that lineage. So this lineage.csv file, which you are going to prepare, which will be the input for this framework, will be containing source set of attributes, like source set of attributes and target set of attributes, plus you will be having the lineage description, and then the what is the logic you want to specify that you are going to display on as a rule, a rule or a logic that is flowing when data is flowing between these two data sets or data sources. Now what this framework does, okay, it extracts the lineage file and it creates objects .csv file and link.csv file, which will be used to extract metadata. So this metadata extracted will be having the description and the logic that is flowing between logic that is implemented between two products, two sources, will be extracted into object and link CSV file, and the lineage CSV file will be having the lineage flow or a data flow between source and source 2. Okay, so this is what the output of the framework at a high level. This is a design of our framework which we have generated. Now let us move on to the next slide. Now how this solution works. So we want to have some scope or how this solution fits so that you can better use this framework whenever you want to reuse it. So how this framework works. Customers, basically you need to follow some file formats, the whatever input template here we are using in lineage.csv. We would expect it has to be a static set of columns in CSV files, so that our IDQ framework will be able to reach that. You can framework will be able to reuse that template and then load the data into 3 files, input files. Now, wherever you are not specifying any transformation logic, So wherever you are not specifying any transformation logic, we convert it into as a no transformations. We want to label it so that there will not be any empty strings, which will not be giving a clear picture. Now, whenever you are putting a transformation logic with some space, multi-word, okay, we want to replace with underscore because we treat EDC will treat this as a name attribute. So which cannot have a you cannot use a multi-word in a name attribute. Now that make sure that there are no special characters. Okay, minimize use of special characters in transformation logic. Maybe you can use arithmetic operators at most. Now input file of so as I said earlier, yeah, input file have to be of same CS, have to be a CS comma separated file, and it has to be having same template so that the IDQ framework will be able to reuse the file and generate the required output files. Now, how this framework flows, how this framework automation flows in this framework. Let us go to that bit. Automation flow. So basically, as I said earlier, the first manual steps will be creating of custom resource, custom model, custom resource type, and custom metadata scanner and custom lineage scanner. Okay, that is one-time task. You can create it manually, or you can use REST API framework of EDC. As of now, I haven't included those creation of resources in this automation framework. What we have included will be uploading the files, and maybe if you want, we can extend this logic very easily with a couple of more curl commands to run the resources also. Okay. Now, once those resources are created, now all that we are expecting used to do is that once you deploy the IDQ workflow, which is generated in our environment, can be reused, can be imported into your environment. Okay, once you import that workflow, you might need to tweak a few changes in the IDQ workflow and in the shell scripts which we have used, just to meet your requirement or your folder structure or your file structure on the Linux machine. Okay. Now this what exactly we do. So in simple, we are going to run a IDQ workflow through a shell script or info cmd command. Now once you trigger a workflow, once we trigger the workflow, it is going to run a few three mappings. So first mapping is going to create object.csv file, and second mapping is going to create link.csv file, and the third mapping is going to create lineage.output.csv file. Okay, now what happens once these three files are created? Okay, we are calling a command task in workflow, which is going to trigger a shell script. The shell script, what exactly the shell script is going to do? So as a prerequisite in EDC, for metadata scanner, you need to upload a zip file. You need to zip object and link file into object.zip file. Okay, the shell script will handle that, convert the input files, the output files which are created by IDQ into as a zip file, and it will upload these two files using EDC REST API framework into EDC. This is how the automation framework works. So basically, the command task is having extra shell script which is going to call EDC, which is going to invoke EDC REST APIs to upload these two files, lineage output on .csv file and object.zip file. Now, these as I said, as part of this workflow, we have a file load shell script, okay, which is going to upload these two files. Now, either you can extend this shell script to simply add a couple of curl commands to run the EDC scanners automatically, or else you can even run the scanners manually from catalog administrator UI of EDC. So at a high level, this is the automation flow which we want to showcase before we jump into the demo. So with this, let us start the demo. As part of the demo, I would like to take you through overall framework and whatever the output we have extracted into EDC. The specific demo on the developer tool will be taken by Sachin following up this session. Now, as we discussed earlier, the first and foremost step is to create a model, custom model uh, to help the EDC to extract metadata into EDC. So this is a sample XML model which we have created as part of this framework. Let me quickly show you that. So this model has got this is more this model is prepared on Google data flow tool, ETL tool. So basically the model works, that Google data flow works in a way like it has project, it has got data set, and under the data set it has got table, and table has got columns. So this is a simple model which we have created as part of the framework. Now once you create the model, the next step is to create a custom model in EDC, in Catalog Administrator. I'm sure you are aware of it. So just click on models, and once you click on models, you can create a new model or you can navigate to the existing model. As part of demo, I'm not going to create a new model. I'm going to just show you what I've already uploaded. So I have uploaded the XML file which I have shown you earlier. So as I shown you in the XML file, it has got project and data set and table. These are the attributes of the ETL, or these are the columns in your input CSV file, which is going to get extracted as part of this framework. Now, once we have the model, what is the next step? So I have created this table to follow the sequence. The next step is to create a custom resource type, which is fairly straightforward in creating. Just click on a resource and click on custom resource type. So once you click on custom resource type, you can create resource type, the required resource type. Let us click on GCP data flow, Google data flow, and then I need to select the custom model which I have created as part of this custom resource type creation. So once you save this one, you can reuse this custom resource type whenever you are creating a similar custom metadata resources in EDC. Now, once we have created custom resource type, the next step will be creating a resource. I have already created the resources in my demo environment. So let me open the resources quickly. So one resource which is going to extract metadata, this metadata is going to have the transformation logic and transformation description, which is as part of the input file provided to this framework. It is a simple, straightforward creation of resource. As I said to you, this resource, this is a lineage resource. So this resource is using a system or a system resource type custom lineage. So this shows the extraction or a flow of data between the data sources. Now let me click on library. Let me open the custom resource which we created as part of this work. So this is a custom resource. 1 second. So this is the custom resource which we have created to extract transformation logic and transformation description. So all that it is going to take is it is going to use the resource type, custom resource type, which we have created earlier, and it is going to upload the object.input file, object.zip file. So basically it is a simple metadata scanner. These two resources needs to be created before you can start kicking this kickstarting this framework. Now let me go into the framework. That means we have created one-time activity, metadata model, resource type, and then we have created a couple of resources. One resource is to extract transformation logic. The second resource is to extract the lineage. Now once you have this, we have already developed the IDQ framework which will take the input CSV file which is provided. Let me quickly show you the format of the input CSV file so that you know what we are trying to extract into EDC. Now, as I said to you, it will be having source and target. Okay, these are the source columns and target columns. This is the GCP on attributes, BigQuery attributes, basically. GCP project, dataset name, table name, and column name, source and target. And this is where we are going to specify the transformation logic in column I and transformation description. So basically, this will be the format. This is a generic format. You can use the same template and fill the data whatever you want, so that this can be reused and can be extracted automatically, this metadata into EDC. Now this is a format of the file, input file. Now let me quickly go to jump into the backend part of this framework. Now in this framework, we are going to use one IDQ workflow, which is having 3 set of mappings to extract lineage output, link object file, and lineage output, link object file. Okay, and object file. Now this mappings are triggered through one single workflow. This workflow will have 3 mappings plus 1 command task. The command task is going to kickstart a shell script, which is going to zip the link and object file into a zip file, and then upload this lineage object output file and zip object file into EDC. Okay, no manual intervention. So we can extend this framework by adding simple REST API calls to trigger these resources, so that you don't even need to run the resources manually. That is not a big change. It's a small change. Now let me get into the backend. So as I said, let us quickly review what we have done in the backend part of it. Now, okay. Okay, let me clear it out. So what I'm going to do, I'm going to open the files. So this is the first shell script which will be scheduled or triggered on based on ad hoc need. So this shell script is going to have an infacmd command, okay, which is going to call your or trigger your workflow. Okay, so this workflow will get triggered and 3 mappings will get executed and 1 command task. Command task is going to call 1 more shell script. Now let me come out of this workflow, sorry, shell script. Let me quickly open the file load.sh. This is a file which is going to upload, which is going to zip the input files in link and CSV into object.zip. This is a prerequisite if you want to upload a file into EDC for metadata scanner. So this curl command will be used to upload the object file into object file into EDC. And this curl command, the second curl command, is going to be used to upload the lineage CSV file into EDC. Everything is automated. All that we need to trigger one single workflow. Let me remove the files which are already created. Object file, we don't need that. And I have a link.csv, we don't need that. Object.csv, I'm removing it, and then lineage output CSV, I'm removing it. This all should get created, and then it should get uploaded into EDC. Let me trigger the first shell script, which is going to call the workflow and then the file load.sh. So this is going to run the workflow and create the object files which are needed for upload. Now, once these object files are created, it is also going to call, as a last step of this execution, it is going to call file load.sh, which is going to create the files here. So object.zip file, this will be exported. This should have been exported into EDC, and then the lineage output.csv file will be exported into EDC. Now, once they're exported into EDC, we can either go and trigger this execution manually, or you can use a REST API. So I have triggered this couple of minutes back just to make sure that framework is working. They have successfully completed. Okay, and then this is the transformation and the transformation description and transformation logic extraction resource, which has successfully run after uploading and triggering it using curl commands. So let me quickly show you the curl commands we have used here. So once these files have got uploaded, all that you need to do is run these two curl commands. Okay, one at a time. We will run metadata scanner first always. So, and then you can add a sleep time, and then maybe after 10 minutes or 15 minutes based on your file size, you can trigger the lineage one. Once this extraction is done, auto connection assignment property has been enabled in this resource, so that the connection assignments will happen properly, and then you will be able to extract lineage into EDC. Now, once either you do it manually or using these curl commands, we can go and quickly check what exactly the output is. The sample output I have captured in this page. This is how you are going to get a sample output. Let me make it bigger and show you. So basically what we are trying to show you is the input resource, which can be a native scanner or a custom scanner. And this is a column, and it is going through this custom metadata scanner, which is displaying your logic that is used. So basically this is checking the flag whether language is French or English, and based on that it is loading into the target table, and this data is further moving into the downstream systems. So this has been extracted in EDC. Let me show you quickly in the system. Let me go to LDM catalog, and let me use the input file to call my resource. So let me call this resource quickly in EDC so that we can check the logic or lineage extracted into EDC. Now this is a resource we have created in this. Let me click on tables. So once I click, I can select any of these tables. Let me select one of these tables. And this table has columns. So let me click on lineage and impact. So this is how how your lineage is getting displayed at summary level. We can flip it to classic view to see at column level. So I can increase the impact to see the lineage. So basically the lineage is flowing between one resource DS1 and the target is DS2, and it is going to this table. Now you want to extend this lineage and see the lineage at column level. You can simply check the lineage. This is how this extraction is going to work. That is this is the lineage which is extracted, and it is able to show you the lineage, and it is able to show you the transformation logic. And if you want to see the description of these columns, okay, you need to click on this column and then click on overview. So whatever description we have added, the source description, okay, that is coming here, which is there here in this column. This is a description field. Whatever we have added in the input file, that has come into source description. The limit will be 1000 characters. You cannot exceed beyond 1000 characters. It might truncate the text. So with this, I want to conclude the demo on EDC side and framework side. Sachin is going to take you through developer tool and whatever framework has been developed as part of IDQ development work. Thank you.
Well, thanks, Rakesh. So now I'm going to show you guys on the, how can we generate the three files which are very much required for the custom scanner and lineage to build in EDC. Those are like, objects file, links file, and then as the lineage file, right? So this is what the input file which we have used a sample of file from the GCP flow, data flow. Okay, so from where to where, and it has even transformations logic and then the descriptions point of view as well. Yeah, so it's a very, very sample one actually. So this being used in an IDQ, Informatica data quality, so as an input file, and let's show you the one which is the object file, right? So this is the file, and then with the help of some of the logic applied in between, and then finally we are generating the the object file, which you could see here, object, link, and lineage output file, and this is the input file which is being used in the mapping itself. Okay, so the next one is all about the links file. So the links file also has the same thing. Say it has the same input file is being used, and then we do have some of the the logic has been applied, and then finally it is right into the links file actually. And the third mapping is required for creating the lineage file with the same input file. Yeah. So I think this is what the input file, and I wanted to show you guys on the the way the output looks like. So this is the object file, and it has its own format to create actually. So manual effort is very tedious, so that we have used our Informatica data quality to generate these files. That would help for complete automation point of view, right? So this is a format it it creates here the object file. The same way it has a the link file. Yeah. So the logic has been applied to create this format of it actually. Okay, and finally, you'll be having the lineage file, how to generate the flow itself, right? That has been captured in the lineage file itself. So these three things got automated with the help of Informatica data quality and with the help of these three maps, right? So each mapping can be run individually also to generate each files, and then they can validate it actually. And for the complete automation point of view, so that if a user wants to run it one by one with the help of workflow, and we have created a workflow to have a complete automation point of view, right? So this is the link object as well as the lineage file, and then we do have finally the command task. So what it does is all about, so it runs one of the script. The script is all about to upload these three files into where the EDC server is there. So because this has to be there in that particular location, so we are keeping that these three files, the output of these three files into the EDC server actually. So that is also automated. And finally, we are deploying it to an application, and then we are running it here. So once you run this workflow, so the lineage maps, each and every object's files are getting created, object link, and then the lineage files, and then finally this is getting uploaded into the EDC server. And then, as Rakesh showed, that one of the another script to run, to execute that in our EDC, the custom scanner execution, and then finally the lineage file of it, right? So this is all about the complete automation. Yeah, thanks a lot.
Hello everyone. If you have any queries, please post them in the Q&A box. We'll try and answer them. Also, the links that you have asked today during the Q&A will be shared with you in the updated slide deck in Success Portal. You'll find that updated slide deck in the Success Portal Tech Tuesdays page. Over to you, Rakesh. Hey, Rakesh, we have one question from Sean. Can we answer that?
Can you hear me, Vrinda?
Yes, we can hear you, Rakesh. Please go ahead.
I need to read out answers here, or shall I type it?
Please read out the questions and answer them.
Okay, sure. Thank you. So, question from Shane is, for the association in the CSV file between data flow and control file. Question is not very clear. My understanding is that, so the control file is your custom model, which will define how is your input data is coming into EDC. That is what the control file is defining, the custom form model, and based on the input file, we are going to generate a link and metadata files. The control file and the metadata files which we are creating as an input file for EDC needs to be matched. The flow or architecture should be matching. The next question is, can the same mapping be created using IACS? Yes, you can create using IACS or any other ETL tools. I have to create data catalog for revenue. Can you elaborate, Shiladi? The question is not very clear, please. So next question is, will the demo files will be made available? Yes, we will upload this deck and we'll update the GitHub links in the PPT. Tomorrow, you should be able to see this in Success Portal, Informatica Success Portal, where this recording will be uploaded along with updated PPT, which will point to the GitHub links. Does this works in EDC 10.4? Yes, it should work in 10.4 and 10.5x also. So next question is from Tamil. What are all the changes with automation that what are all the challenges that with automation I have faced? So the automation challenges will be that is the reason we have defined the scope around the automation, how it works, empty string or special characters. We had faced some issues. That is the reason we have clearly mentioned in the document in the PPT when we showed that, hey, this is the limitations of this automation framework. How will your address transformation logic with regular expression? So basically the transformation logic needs to be in a English text format for this use case. We are not trying to like, even if it can be a regular expression, if we can put it in the CSV file, that should get extracted into the lineage file, and it will be extracted back into EDC. So the next question is, did you will share the do you share the mappings and scripts? Yes, we will share through GitHub link. our technical team has been unable to generate custom lineage based upon the okay, you are referring to a KB article, Shan. Maybe you need to consult your custom success manager and see if you can engage one of the Informatica resource and see if you can able to resolve your issue. Okay, this document is generic document. It should work. We need to validate what you have done at your end before we can comment further. So Venkata, can you please recap why we need to do all this? So basically the requirement or a use case I have initially said covered in the session. Requirement is very simple. Now not all ETL scanners Informatica EDC is capable to extract. So whatever scanners we are not capable to extract, those needs to be created in of a custom metadata scanner or custom lineage scanner. Now you have a question, how can we create a framework to directly extract metadata from a ETL tool which is not supported by Informatica? Example is Dataflow or any other ETL tools which Informatica is not supporting, or any code programming language. The problem here is that we cannot create a single framework for different ETL tools. It is as good as creating a native scanner. That is the reason we have we expect the data to be kept in a CSV file, like whatever metadata you want to extract, the levels of metadata and the lineage along with lineage. So once you have the data in that input file, you can run this framework or tweak the framework to meet your requirement, and should be able to extract into should be able to create input EDC files and extract into EDC. That is the use case of this discussion. Okay, and next. Okay, so we are almost done with all the questions. Any other questions, please put it in the chat room.
Rakesh, we have one question from Shiladi. Can I create just one resource for all tables? Have we answered that question, or?
Okay, I will answer that again. It's been answered by Sachin. So I want to create a resource. I have. How can I create one resource for all this? How can I create a model for this? What is the best practice? See, basically, once we upload the sample files, you will get the model. Okay. Yes, you can create one single resource and extract the metadata. That will be based on your requirements. So one metadata resource usually refers to one single database or a schema. Okay, if you are okay to club multiple schemas or multiple databases into one single resource, yes, you can do it. Toolset will not limit you, but it is up to your use case how you want to define your metadata. You can create. That means in EDC it will be one single resource. That is how metadata will get extracted. Now next question is my question, please. Shiladi, I hope your question is answered. My previous question was not answered.
We have one other question from Satyendra. Yeah. Is it possible to make the data transformation as part of the information logic button instead of as a separate resource? That's his question, Rakesh.
Yeah, there is a way to do it, but for the simplicity, we have created two resources here, okay, to make better understanding. There is a way to create through one single resource.
Thank you, Rakesh. Everyone, we have some more time before we can wind this session up. Please post your queries in the Q&A box. We'll try and answer them. Before we end this webinar, I would like to call out that the session is being recorded and it will be available in the Informatica Support YouTube channel and the Success portal. The updated slide deck will also be present in Success Portal where you can download that. Also, at the end of this session, we have a survey. Please put in your thoughts, your feedbacks, your suggestions for upcoming topics for Tech Tuesdays in that, and we'd like to get to know from you. Let's wait for some more time, Rakesh, before we can end this session. There is another question from Tamil. Rakesh, can we?
Yeah, sure. Can we use web REST APIs as a custom resource? So basically, as you know, we don't have a native scanner. You need to convert your web REST APIs if you want to see the lineage into the input file which we have shown over the demo. Once you convert that into the input file which we shown, you will be able to use this framework and generate the files that are needed for EDC resources, custom resources.
Thank you, Rakesh. Yeah, I think we have answered most of the questions that came in. No new questions are coming in. So let's wind this up. Thanks everyone for joining. If we have failed to answer any of the queries, we will try to get back to you after the session. Thanks everyone for joining. Thanks again to Rakesh and Sachin and Arindam for this wonderful session. See you on our next Tech Tuesdays. Bye.